So, welcome to our first video on Unit 4. Our unit title is Energy and Phase Changes. Make sure when you watch this video that you have the energy and phase change guided change notes here. I will be going through the PowerPoint giving notes on this, so please fill this out as you watch this video. Again, please feel free to rewatch it, pause it, slow it down as you go. Okay, so we're going to start here with a note. And to start off our notes, we're going to talk about what are phases. And phases are the states of substance when they coexist as physical distinct parts of a mixture such as ice water. When energy is added to or taken away from a system, one phase can change into another. So we're talking about the states of matter, right? Going from solid, liquid to gas, or how those go. So those are the different phases. Okay, on a molecular level, when we look at this, is that we know that temperature, we talked about this in Unit 3, that going from solid, liquid to gas of the same substance, temperature increases, which is also the molecular motion, what's happened to particles. But the molecular interactions actually go down. So molecular interactions, the highest is solid. But make sure you understand this graph. So we know that temperature increases going to a gas. We know that means molecular motion is going, but the interactions are actually going down as we go from solid to gas. Okay, so what are the phase changes? And a lot of these you already know. You know, melting and freezing, vaporization and condensation, and sublimation and deposition. Sublimation and deposition are probably the new ones that you don't know. So, you know, when we talk about melting and freezing, well, the melting point and freezing point are the same one. That's going from solid to liquid or liquid to solid. We also have vaporization, which again is liquid to gas. Condensation is the reverse, right? Condensation is what happens on the outside of your drink that's cold. Water collects because it's condensing there. And then sublimation and deposition, that's sublimation is going directly from solid to gas, and deposition is going from gas to solid. So those might be a couple new ones you've not heard before. So a big part of this is still understanding the energy. We know energy is the ability to do work, heat, energy used to cause the temperature of an object to rise, and temperature measure of the average kinetic energy of the particles. So we learned that in Unit 3 about temperature being the kinetic energy of particles. Okay, so when we talk about heat, we're talking about thermal energy. And heat is a form of energy that flows between two samples of matter because of the differences in temperature. Heat always goes from hot to cold. That's kind of that thing when your parents always told you, shut the door, you're letting all the cold air out. Well, that's not true. You're actually letting all the hot air in. So be sure to correct your parents the next time they say that. But remember, it is always hot to cold. Hot to cold. Throughout this unit and throughout this year, you need to always hold that in, that it goes from hot to cold. Okay? And it can be absorbed, which means it's gaining heat, or released, which means it's getting colder. So if you absorb heat energy, your temperature goes up. If you release energy, you're becoming cold. And we have two measurements of units, calories, right? When we talk about that in food, you always hear about calories. Calories is how much energy is in the food. But in science, we use joules, and we will be talking about it in form of joules. So transfer of heat. So let's do some real practice here. So how is heat transferred? A person burns their hand on the stove. So what is the energy going from here? What's the hot thing? Hopefully you got that it's the stove. So it is going from the stove to the person's hand. Okay. Ice is melting on the table. Well, you first have to think, what object is hot? Well, the table is hot. So that means the energy is going from the table to the ice. Okay. Again, a swimmer thinks the water is cold. Well, which one's hot? Well, it's the swimmer, and the water is then absorbing the energy from the swimmer. That's why the swimmer feels cold. Okay. So hopefully that makes sense, and we're ready to move on. Okay, energy in the universe, the system. So when we talk about things, we need to be very particular about what is the system. The system is the thing we're talking about, the specific reaction, um, and then everything else is the surroundings. Okay, so therefore the universe is defined as the system plus the surroundings. So when we look at this picture here, what is the system? Well, the system is the ice, right? Um, and that's what we're talking about, the system here. Sometimes we can define the system including this, and then like the air, right? The air is also being heated up or cooling down based on its contact with the ice. So we need to be specific here about what is the system, specific thing we're talking about, and then everything else are the surroundings. Okay, endothermic. Maybe a new word for you. We need to remember that endo, that's how we break this word down, prefix, endo meaning in, and thermic, of course, meaning heat. So when we talk about endothermic processes, we're talking about the system gains the energy from the surroundings, right? The energy is coming from the surroundings and being absorbed by the system. Okay? They experience a phase change or a temperature increase, and the surroundings experience a temperature decrease. Okay, the example, ice melting in a glass of water. The ice is actually gaining energy, and that's why it's melting. The glass of water is losing energy, possibly also from the air, is also losing energy and being added to the ice. Okay. So there's a big vocabulary word. Make sure you understand endothermic. And then the opposite of that is exothermic. Exo meaning out, and again, heat. So that's how you break the word down. The system loses energy to the surroundings. So the surroundings are actually getting warmer. The system is getting colder in temperature. It's losing energy. Again, that could be a phase change, a temperature decrease, and the surroundings are experiencing a temperature increase. So water vapor condensing on a blade of grass. Okay, the system is losing energy, the water vapor, right? It's in gas form. It's losing energy and condensing back into the liquid phase. So it is losing energy. And then the blade of grass is actually then gaining that energy, or the air, as that happens. Okay. So we need to understand the phase changes in terms of endothermic and exothermic. So again, endothermic is absorbing energy. That means it's going to gain in temperature. So that phase changes are sublimation because it's going from solid to gas. It's increased in temperature to do that. Vaporization, again, is going from liquid to gas. That is an endothermic reaction because it had to gain energy to go from liquid to gas. And then melting. Melting is from solid to liquid, again, gaining energy to make that change. Then the opposite then are exothermic because you have to go cold. So when we talk about deposition, going from gas to solid, you have to lose energy. The system has to lose energy to become colder. Condensation, again, gas to liquid, it has to get colder, therefore it has to lose energy to do that, to change phases. And then freezing, going from liquid to solid, you have to lose energy for that to happen. So you do need to understand endothermic and exothermic in the form of the phase changes themselves. Okay, so kind of just putting it on together, this is a really good, helpful thing about remembering going from which direction. So we're talking heat energy absorbed, meaning endo. If we go up in energy, that means it has to be endothermic. And if we're going down in energy, that means it is exothermic. Okay, and so this kind of just helps memorizing the three endothermic, the three exothermic. And we will be looking at a lot of graphs and information on that as this unit goes forward. So looking at the phase changes, specifically vaporization, that includes two key things, evaporation and boiling. And we kind of know boiling point, and you can see that when you heat up a pot of boiling water, you can see the bubbles are coming all over, it's heated throughout. Evaporation is what happens outside and how we get weather, right? Rain comes, the water cycle comes from evaporation. that only as the surface. And you know that because it never gets 100 degrees Celsius outside, because that would be really bad for us. But we know that water's going from liquid to gas phase and then back forth, and that's how we have the water cycle. Very important to our weather and to water movement. Okay, so remember, vaporization includes both of those. You do need to remember evaporation only happens at surfaces, and that's not actually at boiling point, and then boiling is actually throughout.